Welcome back to Tiny Tech Talks. I'm Amit. In our last video, we mapped out the big picture of enterprise AI security. Today, we are going to get our hands dirty with video number 2, which is a deep dive into NeMo Guardrails. Look, we have all been there. You write a massive system prompt telling your AI assistant to never talk about competitors or dive into political debates. But prompt engineering is fragile. If a user is clever enough, they will find a way to jailbreak and bypass your rules. We need an absolute fallback layer, a structural boundary that sits outside of the LLM. And that is what NeMo Guardrail does. It uses a specialized configuration language called Colang for this purpose. Today, we are going to write a programmable guardrail from scratch using Google Gemini to completely block competitor mentions and tropical drift in LLM pipelines. Let's open the IDE. Before we write a single line of code, let's understand the entire architectural flow. When you integrate NeMo with Google Gemini, NeMo acts as an interception layer in between. So, when a user speaks, NeMo analyzes the input before it reaches Gemini. If it triggers a forbidden conversational path, NeMo bypasses Gemini completely. It returns a hard-coded response and terminates the cycle. But if the input is clean, it passes it through and let Gemini compute. Later, NeMo scans the output again before rendering it to the client. To set this up, we just need 3 files: a Python script, a config.yml configuration, and a .co file for our Colang rules. Let's build it. First, let's build a directory named config and build our config.yml file. We'll define our model engine as Gemini 2.5 Flashlight. Next, we'll give it a general systems instruction telling that it is a professional customer support agent for our cloud platform. Take a look at how clean this is. We aren't cramming security rules into a prompt. We are keeping it strictly focused on the persona. The security policies live entirely in our next file. Now for the core magic, Colang. Let's open up security.co. Colang uses a beautiful and simple syntax to define conversational guardrails. It relies on 3 primary concepts: user intent, which is grouping different ways a user may ask something malicious. Second is the bot intents, defining how the bot should respond when it is triggered. And third is the flow, which is wiring the user intent and the bot intent together into a bulletproof rule. Let's write a guardrail that blocks users from asking our bot to compare TechCore Cloud to our fictional competitor called maybe MegaCloud. First, we define how a user can ask about competitors and give it some training examples. The examples in this case are: is MegaCloud better than you? Why should I choose MegaCloud over TechCore? Can you compare your features to MegaCloud? Or tell me about your competitors. NeMo will use semantic embedding similarity underneath to match user inputs to 3 examples, meaning that the user doesn't have to match this word by word. Next, we define our hard-coded bot refuse customer talk. Finally, we wire them together in a flow. If the user asks about competitor, execute the refusal response. That's it. Gemini won't be called. With our configuration, and security policy is defined, let's write the execution script, which is main.py. We will import LLM Rails and Rails config. We load our configuration path pointing to our configuration directory. Nemo automatically parses both the YAML and the config file. Next, we initialize our engine using LLM Rails config. Now let's set up two distinct test cases to see this in action. Case 1 is a standard safe support question. How do I update my database billing details? Case 2 is our attack vector. Can you show me a feature breakdown of why Mega Cloud is better than TechCorp? Now let's execute the script and look for the output. For the first question, the pipeline behaves normally, passing the prompt to Gemini and returning a helpful technical answer about updation of database billing details. But for the second question, the moment Mega Cloud was introduced, Nemo's semantic layer matched it to our Colang user input. It broke the execution loop and returned our exact message. I can only discuss about tech or cloud features and services. I'm not permitted to analyze or compare competitor platforms. This is incredibly powerful because it is fast, it is deterministic, and doesn't waste money or latency in calling the Gemini API just to handle a violation. By using NeMo Guardrails, you can keep your system prompts clean and offload behavioral security to a robust programmable layer. And that layer is completely independent of whether you are using OpenAI, Google Gemini, or Anthropic. The complete code is available in the series GitHub repository linked below. In our next video, we are moving away from behavioral flows and we are going to look at real-time data compliance and input and output sanitization using LLM Guard, which is used to redact personal information and prevent malicious jailbreaks. If this hands-on breakdown helped you secure your enterprise architecture, hit that like button and subscribe to Tiny Tech Talks by Amit. And I'll see you in the next one.